This video is a sample problem wherein we're going to calculate the stress, strain, and Young's modulus of a string. A string 4 millimeters in diameter has original length 2 meters. The string is pulled by a force of 200 newtons. If the final length of the string is 2.02 meters, we're going to calculate stress, strain, and Young's modulus. Now, let's define the given parameters as the diameter G is equal to 4 millimeters, or this is 0.004 meters in conversion. Okay, the conversion factor for a meter, this is equal to 1000 millimeters. Now, getting the radius of the string, we're going to have the diameter 4 millimeters all over 2. This gets at 2 millimeters or 0.002 meters. Now, the area, cross-sectional area of the string is, we're going to consider the structure of a string has a length and a circular cross-sectional area. So we're going to use this formula as pi radius squared. Now, plugging in the values, this gives us 3.14 for the two decimal places for the value of the pi, multiplied with radius squared or 0.002 meter quantity squared. This gives us the area at 12.56 times 10 raised to negative 6 meters squared, or 1.256 times 10 raised to negative 5 meter squared. Our force is, in terms of newtons, this is equal to 200, and the original length of the string is at 2 meters, okay? And the change in length, delta L, since we are already given with the final length or stretched length of this string at 2.02 meters minus the original length, 2 meters, gives us the change in length of the string at 0.02 meters. Now, we are required to calculate for letter A the stress, B strain, and C Young's modulus. Now, the solution proceeds for letter A as the stress is equal to force all over area. Plugging in the values, this gives us 200 newtons all over the cross-sectional area, which was solved at the given part at 12.56 times 10 raised to negative 6 meters squared, gives us this value as 15.92 times 10 raised to 6 Newton per meter squared. Or this is also equal to 1.592 times 10 raised to 7 Newton per meter squared. For letter B, the string is calculated as the change in length, delta L, all over the original length, LO. The change in length, which was solved earlier at the given portion of this problem, is 0.02 meter all over 2 meters, gives us 0.01 as the value for the string. This is unitless because the meter cancels out. Now, for letter C, our Young's modulus is in terms of stress all over strain. Plugging in the values, for part A, we already solved the strain at 15.92 times 10 raised to 6 Newton per meter squared or pascals all over our strain at letter B 0.01. This gives us our final answer for the Young's modulus of the string at 1592 times 10 raised to 6 Newton per meter squared. Or if we're going to move the decimal point, okay, this gives us 1.6 times 10 raised to 9 Newton per meter squared.